Okay, what's going on, guys? Let's look at this problem right here. Here this question is asking a 200 voltage DC series motor has an armature resistance of 0.25 ohm and a series field resistance of 0.30 ohm. The open circuit characteristic of this motor at 1000 revolutions per minute is presented in figure 1. The first question is asking compute the speed of the motor when the armature current is 25 ampere and when the electromagnetic torque is 36 Newton meter. Okay, now let's go ahead and draw the circuit for this. 200 voltage, V is equal to 200, and series resistance is equal to 0.3 ohm, 0.3 ohm, and then armature resistance is 0.25 ohm, and this is our armature voltage, and the voltage across this is 200 volt. Okay, now the first question is asking compute the speed of the motor when the armature current is 25 ampere. Okay, in order to do this one, first we have to find out the EA values. First we have a condition, that is current is given 25, so we can calculate EA using this formula. EA is equal to V minus IA times R. R is basically R is equal to RA plus RSC, series resistance plus armature resistance. Series resistance is 0.3, armature resistance is 0.25, so R is equal to 0.55, and V is 200 minus the current is given 25 ampere, so 25 times 0.55. 0.55 is addition of these two. Okay, now if you calculate this value, okay, let's calculate. Alexa, what is 200 minus 25 times 0.55?
The answer to your calculation is 186.25.
So this is 186.25. And the next thing is we are going to find out EA2, because we need two conditions, like initially is 25, and then when voltage is 200 voltage, if you compare in the graph, you will see at that time the current is 15, field current is 15 ampere. So we had to use that one to find out the EA2. EA2 is going to be same equation, V minus IA times R. The only difference is IA is going to change. V is same thing, it's 200 minus IA is going to be 15 ampere from the graph, 15 ampere at 200 voltage from the graph. So 15 times R is armature plus series, that is 0.55. And if you calculate this value, this is going to give you 191.71 voltage. And here we have to use, usually we can use magnetic flux that will be directly proportional to N1 or N, like based on if it's phi1, it's going to be N1, directly proportional to N1. But here we are dealing with currents, so this is directly proportional to IA, so it will replace the same thing as whatever the phi replace. And also we have to know one more thing, EA is equal to directly proportional to N. This is the speed. Okay, so these are the two things we have to know before we calculate the speed. So if we create the equation, N2 over N1 is equal to EA2 over EA1, and multiply by phi is directly proportional to IA. It means it's opposite, like IA1 will be on top, IA2 will be in the bottom. Okay, now here our purpose is to find out the speed, that is N2, because initial speed is given, that is 1000. We have to find out the N2 speed. Okay, N2 divided by 1000, that's in N1. EA2 we calculated 191.71. 0.71 divided by EA1, that is 186.25, multiplied by IA1 is equal to 15. This IA2 over IA1, 15 over 25. Okay, so N2 becomes 582.79 revolutions per minute. This is the speed when the current is at 25 ampere. Okay, when the armature current, so this is IA1, this is IA2. Okay, that's correct. Now that's it for the first part. Now let's look at the second part. Second part is asking what is the speed of the motor when the electromagnetic torque is 36 Newton meter. Okay, let's get rid of all these things. (36 Newton meter). Now we know that IA is equal to 15 ampere and V is equal to EA plus IA times R. EA is equal to 200 minus IA is 15 times R is 0.55, and we already calculated that one, that is 191.75. And to calculate the torque, this is the equation: TE2 divided by TE1 is equal to N1 over N2. Okay, now we have the TE, we have provided with TE2 36 Newton meter. That's when we have to calculate, but we have to calculate TE1, that's not given. So to calculate TE1, this is the equation: EA times IA divided by omega. EA is 191.75 times the current is 15. Omega is 25F. Here we have the revolutions per minute already given. Okay, revolutions per minute is already given. We have to convert this one into radians per second. So to convert the revolution into radians, we have to multiply by 25 times 1000, and to convert the minute into second, we have to divide it by 60. Okay, and that gives us 27.46 Newton meter. Now we are going to plug that one right here, and our purpose is to find out N2 because speed is the question. And if we rearrange this one in terms of N2, this is going to become N1 times TE1 divided by TE2. Now what is TE1 and what is TE2? TE1 is 27.46, TE2 is the final torque, that is 36. So N1 becomes okay, N1 is the initial speed, that's 1000 times TE1, that is 27.46 Newton meter divided by TE2, that is 36 Newton meter, and that gives us 762.94 revolutions per minute, and that is N2. And that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching, and if you're trying to learn electromechanical system, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.